So we're going to talk about acceleration. And acceleration is given to symbol A, as you see in the screen, with an arrow over the top indicating that it is a vector. Because it's a vector, it has magnitude and direction, same as every other vector. Its definition is the acceleration is equal to the change in velocity with time. And because acceleration is a vector, a change in direction at constant speed is an acceleration. So as you take the corner at a constant 30 miles an hour, you are accelerating even though your speed is constant because you are changing direction. The definition of delta V is V2 minus V1. So when we substitute this back into the acceleration definition, we get the acceleration is equal to V2 minus V1 divided by t. Acceleration has units of distance divided by time squared. And a couple of examples here. 2 meters per second squared and 1/2 kilometer per hour squared. We're going to do a quick example, calculating example. And we see here a ball rolling across the floor, slows due to friction from 3 centimeters per second to 1 centimeter per second in 4 seconds. Find its acceleration. Now this should be 3.0 centimeters per second. It was a writing error on my part. So we're going to solve this problem. The acceleration is equal to V2 minus V1 divided by t. And notice I'm going with the scalar quantities because we are not given a direction. So the acceleration is V2, which would be 1.0 centimeters per second, minus the initial, or V1, 3.0 centimeters per second, divided by the time, 4.0 seconds. Doing the arithmetic, we see that we have a minus 2.0 centimeters per second divided by 4.0 seconds, giving us an acceleration of minus 0.5 centimeters per second squared. And yes, it is possible to have a negative acceleration, and the negative acceleration is called deceleration, which means the body is slowing down. Now that we have the acceleration equation, we're going to find out how to find V2. And for that, we manipulate, or through algebra, rearrange the acceleration equation to give us V2 equals V1 plus AT. Quick example on how to use the equation. A slider increases speed on 1 meter per second at a rate of 0.5 meters per second squared. Find its speed after 4.5 seconds. Obviously, the slider is going downhill. So we say that V2 is equal to V1 plus AT. V2 is equal to V1, which is 1.0 meters per second, plus A, 0.5 meters per second squared, times the time, 4.5 seconds. V2 is equal to 1.0 meters per second, plus 2.25 meters per second, giving a final velocity, or V2, equal to 3.25 meters per second. We're going to look at an alternate way to find V2, and that's given by the equation you see on the screen. V2 squared is equal to V1 squared plus 2AS, final velocity, initial velocity, acceleration, and displacement. Quick example. A driver brakes her car from 20 meters per second to 5 meters per second in 50 meters. Find the acceleration. Well, to do that, we just use V2 squared is equal to V1 squared plus 2AS. Again, notice we're using just the scalar or magnitudes. So V2 in this particular case is 5 meters per second, and we square it, is equal to V1, or 20 meters per second, squared, plus 2 times the acceleration, what we're looking for, times 50 meters. Doing the arithmetic, we get 25 meters squared per second squared, 400 meters squared per second squared, plus a times 100 meters. Subtracting these quantities, we get minus 375 meters squared per second squared is equal to a times 100 meters. Doing the division, a is equal to minus 375 meters squared per second squared divided by 100 meters. And nicely, this works out to be minus 3.75 meters per second squared. Now notice how this equation is very useful. If you don't have time involved, all you have is some other information like initial and final velocities and distances and so forth. Okay, now we're going to talk about the average velocity of a uniformly accelerating body. As you see there on the screen, this average velocity is different from the average velocity in the speed and acceleration section. There was a total distance or total displacement divided by the total time. Because we are dealing with a uniformly accelerating body, we're just interested in the first and the last velocity or speed, and we take the average by dividing by 2. So our average velocity is the first plus the second velocity divided by 2, or the initial plus the final velocity divided by 2. Now, simple calculation example here. A skier accelerates at 0.75 meters per second from 2 meters per second. Find the average speed after 3 seconds. So to do that, we're just going to use v bar equals v1 plus v2 divided by 2. But in order to do that, we need the value of v2 because we know what v1 is, which is 2 meters per second. So v2 is equal to v1 plus at. v2, initial velocity, 2.0 meters per second, plus the acceleration, 0.75 meters per second squared, times the time, 3.0 seconds, giving us v2 is equal to 2.0 meters per second, plus 2.25 meters per second for final velocity, v2, of 4.25 meters per second. Now, our average velocity, v bar, not v arrow, is v1 plus v2 over 2. V bar, again, v bar is v1, 2.0 meters per second, plus the final velocity, 4.25 meters per second, divided by 2. V bar, 6.25 meters per second, divided by 2, giving us an average velocity of 3.1 meters per second.